today, and you guys don't really necessarily need to see that picture, but a combination it's another arrangement of items, but today order doesn't matter. It's an arrangement of items where the order doesn't necessarily matter. All right, so for this first example, it says 5 men are nominated for the Academy Award for Best Actor, and it says choose 2. Does it tell you at all to like rank them, or does it just say pick 2? You're just picking 2, just because the first one doesn't mean that the first one you name doesn't have to be your favorite. We're not doing a ranking system. You're just picking 2. So if you guys look at those, who would you guys pick for your favorite?
Christian Bale.
All right, so there's the first one I heard. All right, what about the second one?
Leonardo DiCaprio.
All right, so we've got Christian and Leo. Now, some of you maybe, I think sometimes we probably name that, like we probably say our favorite one first, but not always. It doesn't say choose your top 2. It's just pick 2. So order doesn't matter on that one. They would still be both considered our favorites. All right, now in Scrabble. First of all, have you guys all played Scrabble? What? You really haven't ever played Scrabble? Okay, download the app Words with Friends. You can play Scrabble on your phone. So you guys know what Scrabble is though, right?
You get like find words or...
Yeah, so everybody gets 7 letters and you pick them at random, and then you have to try to make a word with the 7 letters, and then different spots on the board are like multipliers, and sometimes it's like a double word, sometimes it's a double letter. So like if you have a double letter or a triple letter, you want to try to, and like they're all ranked with different points. And so like the most common letters are only worth 1 point, but rare letters, which what would you guys consider rare letters? Z, X, Y is pretty common. But they have the numbers that are on each letter tell you how many points it's worth. So like what you guys can see, you would probably want to play an X. Try to do your best to put it on a multiplier, because if you just put it on a regular tile, it's 8 points, but if you put it on a double letter score, that X would be worth 16, and then you build words off of the other letters on the board. I don't know, this is probably one of my grandma taught me how to play this, and like it's one of my favorite games to play, but Zach won't. He refuses to play, but he says that it's unfair because like I pretty much know the Scrabble dictionary because I played it so many times with her. I know like really stupid words, like 2-letter words that no one would ever use, but like OI. No, there's just a lot of random 2-letter words, like whenever you start running out of letters, like you run out of space, and I don't know. It's a fun game to play. But if you don't actually have the board game, I would recommend downloading Words with Friends, and you can play against people you know, or you can play against people you don't know. I'm going to say we have a lot of fun with it.
You know how to play euchre?
Yes. Euchre is a lot of fun. All right, so whenever you are picking these, it wants to know if you have 5 tiles and they're all face down and you just go pick 3 at random. Does it matter which one you pick first, second, and third? No, if you're just going and taking these and grabbing them and picking up 3 out of the 5, you want to know how many different ways that you can pick 3 tiles from a set of 5. All right, so we're only going to do this one time. Let's try to come up with all the ways that we can. What's a combination of 3 letters that we have there out of DOXEN?
Nod.
Huh?
Nod.
All right. Okay, so I heard somebody say DON. If you're just picking them up at random, and the order doesn't matter, is DON the same thing as NOD?
Yeah.
Like if you're just picking 3 tiles up at random and then opening them up, you can later rearrange those, but those are going to be the same 3 tiles in your hand.
Ned.
I'm going to say, is that the same thing? I'm going to say, are we missing any?
Ned.
Ned and end would be from the same letter combinations. Now, could I pick this up? Is that different? Now say, are there any other combinations that we could do? There's actually a couple. Okay. We have what? Yeah, DEN and END would make, those come from the same draw. And I say, can you guys see any more? Huh? I'm going to say NEX. I think that one's unique. I definitely can think of one more. Okay, we got one more. There's one more. What else are we missing? What other combination of 3 letters have we not listed? I'm going to say OEX comes from EXO. What'd you say, Luke? OXN, wouldn't that come from this one? I'm going to say, I'm not seeing it. There's one more because I know that there's 10 and we only have 9 listed. Hang on, what do we got? Oh, I know what one we don't have. There we go.
That's a word.
It's not a word, but we're just saying, like, if these were the 5 tiles left in the stack and I told you to pick 3 at random, what are all the possibilities you could pick? And sometimes you do in Scrabble pick up all consonants and it's really hard to make a word. So there is a formula that actually shows you how to calculate how many, because, I mean, we listed those, but would you want to do that every single time? Trying to list all the different possibilities? You know, say it's really not, it's not time, or it's time consuming, and it's just not efficient. So we do have a formula here. So we had a formula yesterday. Yesterday's formula involved when order matters. today we're picking so many numbers, but it doesn't matter the order that they are in. And so this formula goes by this. N is the number of items in total, and then R is the number of items we're choosing. And if you can see, I'm going to write it a little bigger. The numerator is N factorial, because we talked about that yesterday. Whatever the total is, the amount of combinations that a certain number can be arranged is N factorial. But whenever you are allowed to have repeats or order doesn't matter, some combinations, like we talked earlier, like END and DEN, are the same whenever order doesn't matter. And so we have to take out the ones we're choosing and the ones we're not choosing. We have to consider that there are some repeats that would be counted the same. So if you guys look for that last example, we had 5 tiles and we picked 3. So this is what that is coming from. That's from the tiles. So we had 5 tiles, and then in the bottom we had 3 factorial, and then 5 minus 3, we just plug in 5 and 3 to the formula, gives us 2 factorial. So it simplified this for you. 5 factorial is 120, and we get that from 5 times 4 times 3 times 2 times 1. That's where that number came from. And then 3 times 2 times 1 gave me 6. 2 times 1 gives me 2. And so then whenever I divide 120 divided by 12, it gives me 10. Now, I'm going to show you guys how to calculate this for these things down here. So this is telling me here I have 15 things to choose from, and I'm choosing 3. So this is something like an example. We talked about Subway yesterday. When you go into Subway, you just have tons of options. Let's just say you have 15 options of things to put on your sandwich, but you're only going to pick 3. How many different sandwich combinations could we make? So in this case, my total number is 15, so that's my N, and my R is 3 in the formula. All right, so my numerator, N factorial. You guys all agree that's 15? My total number? Now, in the bottom, my first factorial is R factorial. What is R? 3, so that's 3 factorial. Now, the second part is 15 minus 3. What is 15 minus 3? No, 15 minus 3, not divide. 12. All right, so on this one, oh, hang on a second. All right. I don't say this very often, but for the sake of time, do you guys want to multiply 15 times 14 times 13 times 12, 11, 10, 9, 8, 7, all the way to 1? Okay, get your phone calculators out. I'm going to show you something. All right. So you guys all see your phone calculators like this, probably, right? All right, turn it sideways. All right, so when you turn it sideways, it gives you lots of options. What do you see on the very far left-hand column? Do you see that X factorial button? All right, so if we want to know our numerator is 15 factorial, do you guys really want, you guys don't want to multiply that out, so you can simply do 15 and then hit your factorial button and it gives you an answer. Pretty big, right? All right, let's copy that because that's our numerator. Wait, hang on. Yep. All right, now on the bottom, what's 3 factorial? 3 factorial is 6, right? Now we got to do 12 factorial. So before you type in each one, make sure you clear it out. 12 factorial. All right, now, how would you finish this out? Don't we need to multiply these together? All right, so then you need to multiply 6 times 479,001,600. All right, now we can divide our numerator divided by our denominator. So then we can take, so go ahead and type that in. I don't care which calculator you use.
What are we typing in?
The numerator divided by the denominator. So I multiplied the 6 and the 479 million to get my denominator. Now I'm going to take my top number divided by my bottom number.
Be a decimal.
No, I got a whole number. I got 455.
I did too, but there's decimal.
Ooh. I don't know. I used my. I'm gonna say, did you guys all get 455 when you typed that in?
Yeah.
I just typed in the wrong number.
All right. So it should be 455. All right, so let's do one more of these, and then on example 4, we're actually going to decide if order matters or order doesn't matter. All right, so if I tell you that I have 12 people and I need to choose 9 and the order doesn't matter, I'm just having, like, I type 12 names into the computer and I tell them to randomly pick 9 and I get a list. Order doesn't matter here. So what am I going to plug in for n? What's my total number of people? 12. All right, now how many am I choosing? 9. And whenever you see that C, that stands for combination. In AP Stats, we actually just call that choose. It's like 12, choose 9. But, so for the formula, n factorial goes on top, so that's 12 factorial. Then on the bottom, it's 9 factorial, and what's my second number? 3. 12 minus 9 gives me 3. Now, I do want to show you an alternative. I get it, those are big numbers. Now, on this one, do you guys agree that if I expand 12 factorial out, all right, 12 times 11 times 10, do you agree that that's all that would be left on top? So, do you remember whenever we did division, we expanded all of them out, and if we saw the same thing on top and bottom, we canceled them? Well, if I expanded this, wouldn't the 9 to 1 up here cancel with the 9 to 1 down here? So on this one, what I did is my 9 all the way to 1 from the 12 factorial, I'm canceling it with that 9 factorial. So if you want to expand it out, I'm just trying to show you guys different ways to think about this. If you can mentally think about what's going to cancel, if you wrote it all out, you could tell me what's left, or you can type it into the calculator, or you can expand it all out. I don't care either way. But this way, it does give you a little bit of smaller numbers to work with. So the first thing we need to do is take 12 times 11 times 10. And that gives us 1,320. And then what's 3 times 2 times 1? So then we can divide that, and it will tell you how many different ways you can choose 9 people from a group of 12. All right, so let's take a look at these examples down here. We're going to decide first, does order matter or does order not matter? So on this one, it says, a chemistry teacher divides his class into 8 groups. Each group submits a drawing. How many ways can he select 4 of the drawings to display? So on this one, do you guys think order matters or order doesn't matter? Is there anything? If I divide you guys up into 8 groups and I told everybody to submit a drawing, I'm only going to hang up 4. Does it say he's picking the 4 best, or is he just picking a random 4? All right, so does order matter? All right, so order does not matter. So order does not matter. So this is what we consider a combination. And that is because order doesn't matter. All right, so on this one, what's our total number? How many groups did we have? What was the total number of groups? 8, and how many is he picking? So on this one, we are doing a combination. So we're going to use the combination formula. So we've got 8 factorial and then 4 factorial, but what's the second factorial going to be? 4. All right, so 8 factorial is 8, 7, 6, 5, 4, 3, 2, 1. Now, 4 factorial is listed twice. So the first factorial is 4, 3, 2, 1, and so is the second one. And I'm just putting those in parentheses to show this is the first one, that's the second one. Do we see anything that eliminates?
Yeah.
What eliminates? 4, 3, 2, 1. Does it matter which 4, 3, 2, 1 I mark out? All right, so now we just have to multiply what's left. So for our numerator, we are going to take 8 times 7 times 6 times 5. Tell me what you get. Nope, 8 times 7 times 6 times 5.
1,680.
1,680. And then the bottom, 4, 3, 2, 1. 24. So our last step, we just divide. How many different ways? 70 different ways. All right, now look at example B. It says you will draw winners from a total of 25 tickets. So we know our total number of tickets is 25. And it says the first ticket wins $100, the second ticket wins $50, and the third ticket wins $10. In how many different ways can you draw 3 winning tickets? I want to ask you, does order matter now?
Yeah.
Why?
We should draw it soon. Because there's like,
Well,
tickets.
I'm going to say you're drawing 3 tickets, but does the first ticket have something?
Yeah, you did.
Like,
it's a bigger prize.
All right, so it's a bigger prize. So on this one, order does matter. That is what we talked about yesterday. When order mattered, do you remember, like, we did the class officer and we had a president and then a vice president and then a secretary? On this one, you have a total number of 25. You are picking 3 tickets, but this one is a permutation because order matters. Order matters. I'll say, I don't know if anybody has your, I doubt you guys have your packet out from yesterday, so I will remind you guys. So this is the formula from yesterday. When order doesn't matter, it's still in factorial on the bottom, or in factorial on the top, but on the bottom, it's just n minus r. All right, so on this one, my top number is 25 factorial. What's my bottom number? What's 25 minus 3? Okay, so let's think about this. If I were to expand these two numbers all the way out, what are we going to see the same of on top and bottom? What numbers will we see?
22 through 1.
22 all the way down to 1. There will be a 22 all the way down to 1 on the top. There will be a 22 all the way down on the 1 on the bottom. So what would be the only numbers that are left? 23, 24, 25. And I'm actually going to write it 25, 24, 23. That's the only thing that's left. So we multiply that out. No, and this is just something that I can relate this to. My dad grew up, his family raised racehorses. And so whenever we, as a family, we have been to the horse track, and then in Florida, we've actually went and watched greyhounds race too. And it's fun, but this is just something that you can do. So you can obviously, you can bet on these horses. The Kentucky Derby is coming up soon. Okay. All right, so you can bet on these horses, and it's lots of money. Now, I will say, if you just, there's things called a trifecta. All right, so there's things called a trifecta. And in a trifecta, you are placing a bet on who you think will come in first, second, and third. So if you just bet a regular trifecta, you have to get first, second, and third in the correct order. It's not very expensive to bet, but you have to be exact. Now, you can pay a little extra money to turn it into a combination where order doesn't matter. And can you see why?
Yeah.
Because there's way less ways in a combination. A permutation, there's more chances, but it's a cheaper bet because you have lots of options. So combinations, it ends up being smaller than you do with a permutation, just because in combination, the order doesn't matter, so therefore there's less possibilities. So let me see. Okay, let's look at C, because this is kind of a little review of what we did yesterday. All right, so it says Donna Noble is buying some wedding clothes, and she has it narrowed down to 5 dresses, 2 veils, and 8 pairs of shoes. How many different outfits could she make? All right, so on this one, how many options of dresses do I have? I'm going to say, are we
5 dresses.
5 dresses? How many veils?
Oh.
2. How many pairs of shoes?
8.
All right, so guess what? If I have 5 dresses and I'm choosing one, I have 5 different ways to pick the dresses. All right, how many ways can I pick my veils?
2.
How many ways can I pick my shoes?
8.
All right, what's 5 times 2 times 8? 80 outfits. Oh, let's see. Let's skip D. All right, let's look at E. How many blends of 3 spices can you make from a selection of 8 spices in the spice rack? All right, so do we have a total number? How many are we picking?
3.
All right, so it's 8 and we're picking 3, but do we know, is it a permutation or a combination? A permutation means order matters.
Order doesn't matter.
Why does order not matter on this one? All right, you're picking any 3, but the 3 that you're picking, does it matter which one you pick first, second, or third? Because first of all, you're blending them, right? So if you're blending spices and you're putting 3 spices together and then shaking them up, does it matter which one you put in first? Absolutely not. Order doesn't matter. So this is a combination. So order doesn't matter. So we're going to follow the combination formula. So what goes on top? 8 factorial, and then on bottom? 3 factorial and 5 factorial. Very good. Now, whenever it's numbers smaller than 10, I don't think it's that bad to expand them out. All right, so then 3 factorial is 3, 2, 1. And then 5 factorial is 5, 4, 3, 2, 1. All right, what can we get rid of? 5, 4, 3, 2, 1. All right, so we are left with 8 times 7 times 6 on top. 336. All right, what's 3 times 2 times 1?
6.
All right, 336 divided by 6.
56.
56 blends.
Do we have to label them?
I would say yes. I think it's important that you know what you're actually talking about. All right. We talked about one like this. Let's actually skip down to G. How many ways can you arrange 5 books on a shelf? All right, we have 5 books, we're arranging them. Are we choosing or picking any out of the group, or are we arranging the entire group? You're arranging the entire group, so guess what that is? It's just 5 factorial. You only divide by stuff if you're picking some out of the entire group. If you're arranging the whole group, you don't have to divide by anything. So what is 5 factorial? 120. Do you guys have that one memorized yet? I feel like 5 factorial and 4 factorial you use quite a bit. That's a good question at the bottom. All right, is it appropriate to call a combination lock a combination lock? Think about your locker. Do you have a combination for your locker? Do you know it? I know you guys don't use your locker. But if you guys think about this, is it appropriate to call it a combination? Really? All right, so a combination means order doesn't matter, right? Does the order matter when you do your locker combination? Technically, we probably should call it a locker permutation.
What?
Because order matters. No, it should be a permutation because order matters.
We didn't know that back then.
No, order definitely matters.
Man, did you finish 225?
What?
Okay.
All right. Do you guys have any questions? All right, so if I gave you a problem, would you be able to tell me if order matters or order doesn't matter? And if I gave you the formulas, you'd be able to plug in the numbers, right? Okay, I will be giving you the formulas tomorrow. So there is no assignment tonight, and then tomorrow we will do an in-class assignment. So we will be doing an in-class assignment tomorrow.
But you're giving us no homework because we have 3 grades.
What?
We won't have homework, right?
No, it'll be short, turn it in before you leave, and then we'll be done.